So when you're reading this, all that stuff just means, guys, is you read a graph left to right, just like you read a book. When you read a graph, you read it left to right. No. You always read it left to right, not the other way. So if the graph is going up left to right, we call that increasing. And that's what this means. If you see x2 is greater than x1, if f of x2 is bigger than f of x1, you're increasing. That's it. If the graph is going down left to right, you call that decreasing. Now, I'm just going to make something up really quick. So I'm going to have a point here. I'm just going to say, look, I'm going up and I'm going down. I'm going to call this point A and I'm going to call this point B. By definition, if I were to ask you what are my x coordinates where I'm increasing, I want you to realize that you're probably saying, well, at B, you're not increasing or decreasing, it's flat. But that's not what the definition is saying. The definition is saying you're increasing as long as you're moving left to right, as long as point B is bigger than a singularity or a point to the left of it. And it is. All of these points in blue, the point in red is bigger than all these points in blue. See, so you would say increasing on A to B with a bracket and not a parenthesis. Now, some textbooks have parentheses for increasing, and then some textbooks have it with brackets. Our textbook has it with brackets, but if you don't feel like it's right, like at B, like, oh, it's not right to say you're increasing at B, put a parenthesis. That's fine. That's what I was about to mention. They're not going to take points off because different textbooks, different authors have their different opinions about what's happening at B. And that's a discussion for another day. All we got to know right now is that we're going up left to right, so we're increasing. And if you understand that part, I think you're good. Extrema, I think I said it correctly. That is a Latin word. It stands for extreme, obviously, right? Extrema, extreme. Context clues. You can, if you don't believe me, go ask Miss Marks. She's a very smart lady. She knows pretty much everything about life. And Latin. So yeah, go talk to Miss Marks and tell her, does the word extrema mean extreme? And she's gonna say, yeah. Or just go to Google. All right, you might have heard of something called the extreme value theorem. Have you guys come across that yet? No? Okay, well, this is the first time. All right, so the extreme value theorem, this is what it says. If f is continuous on a closed interval a to b, then f has both a maximum value and a minimum, and a minimum value on that interval. So what does that mean? That means that if it's a closed interval, you definitely have a max, you definitely have a min. That's all it means. And I'm going to draw some examples. So let's draw some examples. Y equals x squared, because that's an easy one. The domain, let's make it from 0 to 2. Notice that I put brackets. So y equals x squared, 0 to 2. 0, I'm going to say that's 2. I'm increasing from 0 to 2. I have a minimum. These are closed. There's my min. There's my max. That's it. That's all it means. Should we do different? Okay, what if we don't have closed? What if we don't have closed? Let's do y equals x squared again. And I know this is not even asking that. What if my domain is from 0 to 2? Notice I only have a 2 on the bracket and with a 0 in the parenthesis. And so open circle, open circle. I tried to make it look parabolic there, guys. Closed circle. This one has no min, but I definitely have the max. No min. Yeah, because it's not closed. Is it a closed? Well, how close? You can get infinitely close. How close do you get? 0.1, 0.01, 0.0001? Exactly. Do you see the issue? You can always get even closer and closer. So you can't call it a minimum anywhere. Do you see the issue or no? All right. So what if I have, let's do another one. And notice this to my domain. It's the same thing, right? 0 to 2, but no brackets on either or. Open open. No min, no max. Don't get this confused, guys. Just because I do not have a closed interval does not mean that I have no max at all or no min at all. In this case, I don't have a min or max. But if you have something like this, I'm just going to make it up, guys. I'm running out of space here. Let's do a semicircle. Already, okay. Semicircle, open circle, open endpoints. No, but that's okay. If I have something like this, I do have a max, but you have no mins. Did I get enough sleep? Because of all the, I can't talk right, I can't speak right, I can't write correctly. So that's what it means, guys. So hopefully that made sense to you guys. I'm gonna try and go as slow as I can with this subject. It's pretty easy, it's relatively simple. So, all right. Notice that there's a dot. Well, I guess I'll fill in the dots for you guys. Everywhere you see a red dot, those are called critical points. Put critical. Yeah, we're going to talk about that right now in a little bit. Critical points are where f prime equals 0 or f prime is undefined. Critical points are possible candidates for maxes and mins, as well as endpoints. So because I already put little red dots for critical points, the little blue dots that you see here are endpoints. Look at me color coding everything. This is a closed interval. So you're always going to have local mins and maxes and absolute mins and maxes. Oh, we got to talk about local and max and okay. So these words are interchangeable. I'm going to write it down here. If you see the word local, that means the same thing as relative. And it makes sense, guys. You're like, I don't know, if your uncle lives locally, he's your relative. I guess that's like, close proximity, maybe. I mean, I don't know. So if you, these words are interchangeable. So don't freak out when I tell you find your local mins and you log into Delta Math and, oh, Delta Math says find relative mins. What does that mean? It means the same thing. It means the same thing. No, I'm not. I'm not mocking. I'm not mocking anyone. When you read the AP exam or any question and it says relative instead of local, don't freak out. They mean the same. All right, absolute. So absolute, guess what word you can interchange with absolute? It starts with a G. Good. No, not good. Second letter L. I'm sure you've heard of this word in math class. Third letter O.
Global.
Global. Absolute and global are interchangeable. When you use the word absolute, you're saying that is the absolute biggest or absolute smallest. That's the absolute max. There is no point bigger or higher than that. That's the absolute min. There is no point with a smaller or lower than that. Does that make sense? Now, this whole, all of these critical points and endpoints are candidates for global mins and global max. There's only going to be one global max. There's only going to be one global min. Now, all of them, well, okay, sometimes it's neither, but all of them are candidates for relative min or relative max. It could also be neither if nothing happens there. Does that make sense? Don't worry. Okay, you're looking at me like, no, it doesn't make sense. Okay, look, let's start. You see this point A? I'm starting left to right, guys. I'm going to read this left to right. In the vicinity of A, Are all these points to the right of A, are they bigger than A? So then that means that A is a relative min. So let's write that down. I'm going to put relative min. Oh, global means it's the biggest or it's the smallest. By the way, a global is also a relative. We'll talk about it when we get there, don't worry. At x equals 1, are all the points to the left and to the right bigger or smaller than at x equals 1? At x equals 1, it's a relative what? Max. It's a relative max because all the other points are lower than at x1. Sorry guys, I need it. From A to x1, all those points are below x1. Are below, yeah. All right, and then at x2, I'm gonna call this a relative what? Min. I could also call it a local. You know what, I'm gonna start using local because I put the word local over here. All right, at x3, is that anything? No, that be careful. If you're only counting points from x2 to x3, it would be a relative max. But look at from x3 to x4, all those points are higher. Yeah, you have to look at both directions. So then in this case, this is neither. You have to look at both directions to decide whether it's max or min. At x4, this is, I'm gonna call it local instead of relative. It's the same thing, guys, it's the same thing. This is a local what? Local max. At x5, that is a local min. x6, what is that? Neither. What about B? Perfect, local max. How do we feel so far? All right, don't, hold on, we're not leaving yet, guys. We're not leaving yet. Which one of these is the absolute max? It looks like x4 is the absolute max. We're gonna say it is. We're gonna go, oh look, it's higher. Absolute max. I should have made the B one a little lower. Next time I'll do that. Which one looks like the absolute min? Absolutes are also local, are also relative, because in the vicinity, those are either the lowest or highest points. So absolutes are also relative. Cool or not cool? All right, hold on. I wanted to say something about this. Okay, let's look at the derivative. I want to know what's happening to the left of that critical point and to the right of that critical point. So let's look at this derivative between A and x1. This is a function f, by the way, see? It is a function f. So notice that I'm going to be putting f prime. Between A and x1, is my derivative positive or negative? No. Oh, yeah. Sorry, guys. Sorry. Derivative is positive. Derivative is positive. That's how you say derivative is positive, guys. F prime greater than 0. Between x1 and x2, the derivative is negative. So f prime less than 0. That's an F, it just came out. Between x2 and x3, f prime is greater than 0. Between x3 and x4, perfect. F prime is greater than 0. Between x4 and x5, f prime is less than 0. Between x5 and x6, greater. Between x6 and b, greater. Okay, so put all that down, and we're gonna make an observation. You guys ready? Let's observe what is happening at our critical points. Look at this, look at x1. To the left of x1, my derivative was positive, but to the right of x1, my derivative is negative. And note that we have a max there. Positive to negative, max, okay. To the left of x2, the derivative is negative. To the right of x2, the derivative is positive. Negative to positive. Oh, I have a min there. Okay. The neither, the one in x3, there is no sign change. F prime is positive to the left, and F prime is positive to the right. Look at x4. F prime is positive to the left of x4, and F prime is negative to the right of x4. And there's the max, positive to negative. F prime is negative to the left of x5, F prime is positive to the right of x5, and that's a min. At x6, there is no sign change for F prime. Do you guys see something going on? Yeah, there's definitely something going on. So here's what we were talking about a little earlier. What is a critical point? A critical point is where the derivative is 0 or undefined. Does not exist. Why are they called critical points? Because something is happening there, as you saw right now. Oh, man, Norma makes a really good coffee, guys. Huh? She said that earlier? Hello, Greta, if you are listening to this video. Corollary 1, I don't care about names. Obviously, I took this from some textbook. If you want to know what textbook I took it from, it was a Denana textbook. Like I said, our textbook uses brackets, as you can see by evidence here. So you're increasing on A to B, there it is. If your derivative is negative, you're decreasing, and there it is. Just notes. If you were to use parentheses instead of brackets, relax, no harm done. Most professors, or okay, depending on what your professor says. If your professor says parentheses, use parentheses. If your professor says brackets, use brackets. What is College Board going to do? What is AP going to do? They're not going to take points off. No, they'll read with you because textbooks are all different, authors are all different. Some will put parentheses, some will put brackets. Okay, more notes. It says there's this deal called a first derivative test for local extrema. And we already saw an observation. So let's chat scenarios. Okay, if F prime changes from positive to negative at C. Okay, ready? I'm gonna do two scenarios. I'm gonna call this C, and I'm gonna do F prime of C equals 0, and I'm changing from positive to negative. So here we go. F prime of C is positive here. Not C, F prime. F prime there to the right of C is negative, and we call that a max. If you want to call those endpoints, then you can say absolute max, but I'm just stating that it's a max. Let me do another graph, and this time I'm going to make C, F prime of C undefined, or does not exist. So here we go. Notice F prime is positive, F prime is negative. I still have a max. Yeah, and they're both max. It's just that one is the derivative is 0, and the other one the derivative is undefined or does not exist. Extrema means extreme. So local extreme means find your local max mins. All right, let's keep going. Scenario number 2, F prime changes from negative to positive at C. So if you want to get ahead of me, guys, I'm going to be doing 2 scenarios on all of them. And no yawning, miss. Here will be, let me do a better one. We'll do a bird there. On this one, f prime of c is 0. On this one, f prime of c undefined. Notice f prime is negative there, f prime is positive. F prime is negative, f prime is positive. We have a min, we have a min. F prime does not change signs. Okay, let's see. F prime is positive, f prime is positive. Neither, that's a C. F prime of C equals 0. Increasing, increasing. Let me make this one flatter. Later. No, I don't want to put an arrow there. And I don't want to put an arrow. I should do what? I was, okay, well, no, I already drew it. There is no sign change. F prime does not have a sign change. Nothing happened. Neither. I got other scenarios now. It tells me at a left endpoint, and the endpoint is A. Okay. Here's my left endpoint, A, and they tell me that all my x values are larger than A. So here we go. Here's A, left endpoint, and f prime is negative. What do we have? A max. Here's an endpoint A. And now they tell me that my derivative is larger, is a positive number. So I'm going to write it right here, and I'm going to go, what do we have? A min. Is all this making sense, guys? Virtual class, you guys have been pretty quiet today. What am I going to do when I get evaluated, guys? Is the virtual class going to be really quiet? That wouldn't look good on my part, on my behalf. I would get bad ratings on the domain for classroom participation. All right. This time I'm looking at a right endpoint. So I'm going to say that's my right endpoint, that B. And all the x values are smaller than B, and the derivative is negative. Okay, derivative is negative. Let's do this like this. I'm going to say that's my endpoint there, and I'm going to go, and there it is, derivative negative. What do you notice? That is a min. Endpoint, right endpoint at B. This time they tell me that my derivative is positive. Max. All right, I think we're ready, guys. I think we need experience, of course, but I think we understand the basic foundations of what's happening to a graph of f based on the derivative. If the derivative changes from positive to negative, that means f has a max. So think about it. If f is changing from positive to negative, if f prime is changing from positive to negative, that means that f was increasing, and then at some point, it stopped increasing and started decreasing. So with your hands, you can't see right now, but these guys can. I went up, increasing, and then down, decreasing. So there has to be a max. If your f prime goes from negative to positive, I went down, decreasing, and then I went up. So there has to be a min. Okay, what? All right, let's see what we got here. It looks like we have linear lines. Oh, did I answer this already without doing? Oh, it wants me to answer. Okay. It's a multiple choice. Sorry, guys, I didn't remember. It looks like all these are linear lines. And so let's see if we can just draw an image first. I think that's the easiest part. So let's draw a grid. And at 0, let me see, at 0, okay, so I'm gonna have to go a little bit below. Let me put this x-axis right there. At 0, you're at 0, so put a point at 0, 0. At 1, this would have been a -3. So 1, -3, I'm gonna say here's 1. And I'm gonna say -3 is right here. For the moment, it's a circle. And then let's see, 1 minus 4, and then so fill in that circle, guys. Not because of equation 1, but because of equation 2. Equation 2 is a linear line from 1 to 5. I'm going to say 5 is like right there. And when x is 1, that linear line, this one, has a y value of -3. So you can see it fills in that circle because of the equal sign. 5 minus 4 is 1. So I'm going to say 1 is like right there. And it's a solid circle, and connect them. Again, at 5, 6 minus 5 is 1. So it's an open circle, but at 5, the equation number 2, let me give them numbers. Let me give them names. Equation number 2 fills in that circle for you. So let's see, I'm going to go all the way to 9. I'm going to say 9's right here. 6 minus 9 is -3. So I'm going to go back to -3, and that is going to be a solid circle. All right, connect them. They're all linear lines, guys. So all of them should be straight linear lines. This is F. And now you can see what's happening. Without doing anything, we can see that we have a min at 1. We have a max at 5. Is this a closed interval? It is. And we have another min at 9. By the way, at 9 and at 1, those are absolute because they're the same value. And this is absolute. And all absolutes are always local because locally, that's the only max. No. In this case, why did we make an exception on this one? Because they're both the same value. Unless I made a mistake. 6 minus 9, -3, -3. Nope, no mistake. All right, let's read. Critical numbers at 1. Okay, that's I'm reading letter A. That's true. Local and absolute min, f of 1 equals -3. Local min, f of 0 equals 0. Oh, I didn't even label that. Okay, hold on, let's label everything, guys. At 0, at the origin, what is that right there? A max. This one's out because it told me that at 0 I have a min. And that's a local min. Letter B, no critical numbers, no extreme values. That's a lie. All my critical numbers are where my derivative is undefined. So x, let me put it here on the side, x equals 1 and 5. Those are critical numbers. Chavez, what do you call 0 and 9? 0 and 9 are what? Endpoints. I probably should have used a different color. Sorry, guys. Let me circle it with a different color.
So endpoints can't be critical numbers?
No, endpoints are not critical numbers. I mean, I guess something could be happening. You can have a vertical tangent at an endpoint, But by definition, I would call it an endpoint and not a critical number. Critical number has to happen within inside the domain. Let's go back to the definition. I probably should have told you that. A critical number has to happen inside the domain. Inside the domain, not the brackets, the parentheses. You know what I mean? Okay. Let's see. Critical numbers 1 and 5. So far, that looks good. Local and absolute min f of 1 equals -3. Yeah, that's true. Local max at f of 5 equals 1. That's true. Absolute min f of 9 equals -3. That looks good to me. So it looks like letter C. Let's read letter D just in case. Critical numbers at 1 and 5. Local and absolute min f of 1 equals -3. Local and absolute max f of 5 equals 1. Absolute min f of 9 equals -3. Okay, there has to be some subtle difference somewhere. Yes, 9 is local and absolute min. Absolute min, local and absolute min. There has to be an error somewhere. What's the difference between C and D? Local and absolute. Okay, the more correct answer is D then. Yeah, it's still not the most correct. You're right. More correct. This is a UH question, by the way. I apologize. Letter D is the most correct, guys. It's not the best correct, like Miss Tiff was saying. The best correct would be to say what? Yeah, local and absolute min at f of 9, local and absolute min at x of 1, absolute and local at f of 5, local max at 0, local, yeah, that's it. That would be the most correct, but they don't have that. So letter D is the best one. I'm gonna delete this one for the future. I'm gonna put here for future notes, delete Q, insert better. At the end of the year, guys, I print out all my notes and I redo them. I guess I didn't catch this question last year. All right, let's keep going. With no calculator, because I know you can just use a calculator to find this. It says, for what values of x does this function have a relative max? You guys ready? So the way you tackle this question without a calculator, you find where the derivative changes signs. So I'm going to put some steps. Step 1. Oh, accidentally. Step 1. Hold on. Find critical number. Find critical numbers. Notice they do not give us an interval. So if I have a max or min, it's going to happen at a critical number because they didn't give me an interval like to check my endpoints. That's what I'm trying to say. Does that make sense? Okay, no yawning. Yeah, so there are no endpoints. My domain's all row numbers. If I have a max, it's going to happen at an endpoint. It's going to happen at a critical point. Man, I'm full of it today. All right, so let's find critical numbers. How do I find critical numbers? Take a derivative, equal it to 0. In this case, if I had a rational function, you could maybe equal it to undefined, but make sure it's not a vertical asymptote. So here we go. I have a polynomial. Just take a derivative, equal it to 0. F prime of x equals first times root of the second, 2x minus 3 to the power 1 times 1 plus second times root of the first, so times 1. We still okay, guys? Now comes algebra. Let's see, all this is together. I see that I can factor out an x minus 3. So here is an x minus 3 factored out. Giant parenthesis. I see the 2 times x minus 2. So I see 2x minus 4 plus x minus 3. Have I confused anyone? I guess I could have done it in less steps, but x minus 3, I'm going to combine like terms. 2x plus x, that's a 3x. -4 minus 3, 4, 5, 6, 7. That's -7. I'm going to equal that to 0. I'm equaling to 0 to find critical numbers. That's a number sign, not a hashtag. All right, here we go. Where do I get this equal to 0? At 3 and at 7/3. Those are the only two locations where I can have a sign change, a possible sign change. So if it's not any of those two numbers, I would delete. 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 -3 is in there, so that's out. So it's between negative, actually, you know what? All of them are out. Oh, that sucks. All right, well, yeah, we're teaching to the test. We're not teaching to the test. Call that F prime, guys. 7/3 is a number smaller than 3, because if you remember 6 divided by 3 is 2. So 7/3 is 2.333. So I'm going to say that's 7/3 right here. And I'm going to call this 3 right there. I don't see any mistakes. So how the way you do it, you notice that this is F prime. I'm going to plug in a number to the left of 7/3, like 0. If I plug in 0, I get negative times a negative, which is a positive. I'm going to plug in a number between 7/3 and 3, like 2.5. No, you don't need a calculator. 2.5 minus 3 is negative. 3 times 2.5 is a number bigger than 7. So that's positive. Negative times a positive is a negative. Hold on. 3 times 2.5, 3, 6, 10. Oh, yeah. Right? 6. What's wrong with? Oh, yeah, definitely. If I choose a number bigger than 3, like 5, positive times a positive, positive. Okay. You can see here that my derivative is changing from positive to negative at 7/3. So that has to be a max. And then at 3, I'm changing from negative to positive. So this has to be a min. How do we feel? Okay. Yeah, this has no absolute, guys, because it keeps going for up forever and it keeps going down forever if you were to read right to left. Oops, I almost dropped my laptop here. Okay, that one's pretty basic. Find the intervals on this graph where it's increasing. All right, ready for the intervals, guys? I'm going to take a derivative because I'm finding my critical number. 7 times 4. Okay. 28, that's cubed. 4 times 3. I'm going to set this equal to. Yeah, if you have a polynomial, set it equal to 0. I'm going to find my candidates or my critical points. I'm going to factor out an x squared. And what else can I factor out? Can I factor out a 6? 4? Excuse me. 4 goes into 28 7 times. 7x plus 4 goes into 12 3 times. I don't see any mistakes anywhere. So I see that I have a double 0 at 0. And I have another 0 for f prime at -3 7. We're okay so far, guys? All right, so here we go. I'm going to do a number line. It goes on forever. I'm going to call that number line f prime. I'm going to put somewhere a 0. And I'm going to put somewhere a -3 7. And maybe I might need help with the in between. We'll find out. I'm going to choose a number to the left of -3 7, so like -1. So if I put -1, this is always going to be positive. Always positive. -7 plus 3, that's going to be a negative number, so negative. If I put a number between -3 7 and 0, so let's do like 1/10, -1/10. That's a number smaller than -3 7, right? Yeah. Negative 0.1 so that's negative 0.7 plus 3, positive. I see positive. And if I see a number bigger than 0, I see positive as well. So, oh, okay. I like this one. So I am increasing from negative 3/7 to 0. And then for a moment, I'm stopped. And 0 to infinity. Is there a better answer than this? Yeah. The best answer is this. Or I guess if we're following the book. If we go by the definition, every point to the left of that point is smaller at that point at 0, and every point to the right of that point is bigger. So I'm increasing on the entire interval. Do you know what I'm trying to say? I'll give an example. All right, so Godina said, but at 0, you're not increasing. Or Godina, sorry. But remember what the definition says, guys. The definition for increasing says this. So don't worry, I'm gonna help you out. So let's look at a function, and don't write this function down. I'm just gonna, let's look at this function. This is besides all this stuff. So this function y equals x cubed looks like this. Does everyone agree? And if I were to take the derivative, you'd get y prime equals 3x squared. If I equal that to 0, that only happens at 0. And if I were to do a number line and call that f prime, I put a 0 there. If I choose a number to the left, that's positive. Choose a number to the right, that's positive. At 0, it's 0. All right, I get this situation happening. But notice, we don't say for this function y equals x cubed, we don't say increasing negative infinity to 0 union 0 to infinity. And I guess you could, but you don't say that. You say increasing an entire domain. Increasing in entire domain. Why? So the question that we're debating about is 0. At 0 itself, at 0, 0 for this one, you're not increasing or decreasing. But that's not what the definition for increasing says. The definition for increasing says, at this point, if I were to zoom in extreme, so here it is, I'm zooming in extreme. That's me zoomed in extreme. At this point, to the left of that, all these points are lower. To the right of that, all these points are bigger. So by definition, I am increasing throughout that a whole entire domain. Does that make sense? Yeah, Kana? Ordinance? Tiff? Okay. All right, guys. Do you guys feel we can take some more, or do you guys want to take a break? We have 2 more? Okay, let's keep going. Oh, we should use Desmos to look at this one though. No? Okay, let's keep going. Yeah, you guys, whenever you guys get a chance, do an exploration one. We'll do it for this one. Find the intervals on which this function is increasing. All right, what rule do I gotta use? Quotient. First, we realize before we do anything, do I have any vertical asymptotes? We don't have, because the denominator will never be 0. Notice it's x squared. No vertical asymptotes. No, it's because it's not. I mean, I guess, well, now you're going into abstract. There is something going on, but those are complex numbers. All right, no vertical asymptote, guys. By the way, if you were to do an XY plane with the complex plane coming outward, like a 3D, it would look very cool. But that's already like at the university level. All right, here we go. I'm gonna find my critical points. Find critical. I'll find critical numbers. So how do I do that? I take a what? Derivative. F prime equals quotient rule, bottom, times the root of the top minus top times the root of the bottom, all over bottom squared. The only way, this will never be undefined because I'll never get the bottom to be a 0, but I can't get the numerator to equal 0. So I'm just going to set the numerator part equal to 0. Six x squared plus, ooh, okay. If I have 6 quarters, 50, $25, $1.50, and then subtract 6 from that, 144. Oh, that's 50 cents, so I'll double that. 144, 288. Really? Oh yeah, because I needed to factor in another 6 in there. Good job. Yeah, because it's 49. We didn't do, I did 24, so I did 48. Dummy. Minus, and then that's 12x squared equals 0. We still okay? All right, so I see a negative 6x squared plus 294 equals 0. That's a 4. It just came out looking like a 9. Well, I just did these two. I'm gonna factor out a 6, a negative 6. I mean, I guess it's the same thing if I move the 294. No, I want the 0 on the right. I'm gonna factor out a negative 6 x squared minus, how many times does 6 go into 294? I guess we're gonna need a calculator. How many times? 49? Oh yeah, because that's what we did earlier. Dummy. All right, there's my critical numbers. Now it's a difference of squares. Now that I got my critical numbers, I do my little number line. Sometimes they call this a railroad tracks. I call this F prime. And I'm just gonna choose numbers. You can put it into the original, it doesn't matter. I'm gonna choose numbers, yeah, it's easier for me. I'm gonna choose numbers and I'm gonna put it in there. I don't care about the denominator is always positive anyways. So if I choose negative 10, negative 10 squared is 100, so I see positive on this side. And then, let's see, negative 10, negative, negative, positive, but I see a minus. Ooh, that's not gonna help me. I'll put it on this one then. Negative 10 squared, 100, 100 minus 49. That's positive, positive times a negative, negative, negative. If I plug in a 0, negative times a negative is a positive. If I plug in a 10, 10 squared minus 49, that's positive times a negative, negative. They want to know where I increase. Increasing on interval. Oh, they just say interval. I guess it's safe to just write this. No, I want to put brackets. How do we feel, guys? All right, last one. Use the graph of the function f below to estimate where f prime is 0, positive, and negative. Ooh, I like these. These are fun. Where is f prime 0? That's the easiest one. And where else? And 1? I just heard you say -1. I'm sorry, miss. All right, let's do the f prime negative because there's only one interval for that. Where is f prime negative? Yeah, so it's an interval. So go like this, -1 to 1. And where is f prime positive? Negative infinity until you hit -1. Now be careful. You know what? Okay, on this one, do put parentheses. It doesn't matter. It doesn't matter, guys. On the AP exam, they'll still kind of right. But on this one, put parentheses. because now we're looking at a behavior, f prime positive, f prime negative. Negative infinity to -1, union, and then again from 1 to infinity. That makes sense? Yeah, we're not asking for increasing, decreasing, guys. So let me take a sip. In case you're wondering, like, Chavez, why did you put parentheses and not brackets? Let me tell you why. They're not asking for increasing, decreasing. You increase and decrease on an interval. Do we understand that? But this says, where is f prime, 0, positive, and negative? They're not asking for where is f prime greater than or equal to 0. Bless you. Oh no, stop yawning. They want to know where f prime is positive. Well, guys, at -1, right at -1, when x is -1, f prime is not positive. F prime is literally 0. So we cannot put a bracket right here because at -1, it's not positive, it's 0. Does that make sense, virtual class?
Yes.
Okay. Now, if I were to tell you where am I increasing, if I were to tell you where is this where is f increasing, then you would say -infinity to -1 with a bracket and 1 with a bracket to infinity. That one you could say, because that's asking for where am I increasing? Where is f increasing by the definition? On which one? No, we can't put a bracket on that because we're not asking for where am I decreasing. If I ask where is f decreasing, then you would say you're decreasing -1 to 1. But are they asking for where is f decreasing? No, what are they asking? Where is f prime negative? No, it's the context. The context is like right at -1 and right at 1, the f prime is 0 because you have horizontal tangents. Yeah, but if they're asking where am I decreasing, decreasing is an interval. But if for the derivative, where does this behavior happen? No, between -1 and 1, f prime is negative. But at -1 and at 1, f prime is 0. Does that make sense? Did that make sense, virtual class?
Yes.
Okay. All right, let's come back.